Hello everyone, my name is Nanapu Sirisha. I am studying in third semester in Computer Science and Engineering in Sri Venkateshwara College of Engineering. Today our topic is applications of Fourier sine transform. In this sine transform, we are studying about the few overviews. In these overviews, we are studying about the what is Fourier sine transform and applications of Fourier sine transform and formulas and infinity wave train and inverse sine transform on organization of the book. In this Fourier sine transformation, we have the few definition where Fourier sine and cosine sine transform the f of x, where f of x is also called the sine transformation pair, and the function of f of x and f of c. Fourier transform and the knowledge of either f of s and f of c enable be recorded. In this sine transform where f of s is k of function, we have considered the function of f of k is implemented as Fourier sine transform, where that sine transform is f comma x comma and k. In it has the difference choice of we can use the a and b. We can by in this b we are used by passing the optional Fourier parameter, where in this Fourier parameter we are using a and b. In this work, a is equal to 0 and b is minus 2 pi. The numerical factor of Fourier sine transform are defined uniquely. Only the products only we can use in sine transformation, where that Fourier inversion formula not have any numerical factor, and factor of 2 appears because of the function has L2 norms of. Next, we are studying about applications of Fourier sine transformation. In this application, the Fourier transformation can be used to calculate where f of x of a given function, provided of course that is integral exists. Calculation of where f of x and f of x is referred to a Fourier transformation, while the inverse operation calculation of f of x and f of k is called Fourier inversion. This is the small diagram of the Fourier sine transformation, where a is equals to minus 2 and a is equals to 1. We have taken the three functions of a, where pi is equals to 12 and theta is equals to 4 and x is 0 and byte is equals to 0.8 and t is equals to 2. We'll get the output like this. We are studying about few formulas of Fourier sine transformation. This is the 4 formulas of Fourier sine transformation. F of CW is equals to minus 2 by pi of 0 plus W f theta SW. These are the few examples. Next, we are studying organization of the book. The book organized terms in this sine transformation, definite and general properties of classical integral travels and the transformation, Fourier transform and Fourier sine transformation. The general property of this continued transform, such as integration and the linearity, shift in time and frequency. In this organization, we are finding about the linearity, frequency and time. It has the differentiation of time and frequency, asymptotic behavior, integration in time, frequency and conversion in time. Next, we are studying infinity wave train, where infinity is the name. Important application for the Fourier transformation is the infinity placed into some sinusoidal wave. Imagine that an infinity wave train is Sine W0t is clipped by carousel or steerable diet cell. Suppose so that we have 20.31. This corresponding to n cycle of our original wave train. Where sine f of t is ordered, we can use the Fourier sine transform. Where this is a small example of that, where f of t is equals to sine w0 t. T1 is greater than n pi by w0, where t is t less than n pi or w0. We are using this formula. Infinity wave train, where GSW is equals to root under 2 pi to sine and square bracket W0 minus W n pi by W0 whole divided by 2 W0 minus W minus sine square bracket sum open bracket W0 plus W into n pi by W0 divided by 2 W0 plus where this is the small wavelength of the infinity wave train in sine transformation, where f of t with the t is equals to pi by W0. Inverse Fourier sine transformation. Next we are studying about this. In this sine transformation, the analysis of the preceding subtraction can also be applied to the Fourier's cosine and sine transform formula of all three varieties of the Fourier transform and their respective inverse. But this our function where f of t is even, then the customized transform will reproduce it faithfully for negative t, where odd function will be properly described on negative t by this sine transform. In this sine transform, t has the negative value. Inverse Fourier sine transformation formulas, where g of w is equals to 1 by root 2 pi. This is the formula where g of t is equals to 1 by root pi to lambda minus infinity GWE minus IWT dW. GCW is equals to whole root 2 by pi, where infinity is 0 and infinity. F of ct is equals to cos what dw. GSW is equals to whole root 2 by pi lambda 0 infinity. F of t is sin wt dt, where f is t is equals to whole root 2 by pi lambda 0 infinity. G of w is sin wt dw. We are using these formulas in Fourier sine transformation.